So that's the first invention, a Spider-Man improved web slinger at 10 years old.
It's not like you start your company and then everything is done and ready. No, that's when the real grinding starts. I put all my savings on the patenting fees and R&D development. If we wouldn't have funded our company and raised the pre-seed money, it would have been game over.
So you wouldn't have just been unemployed, you would have been unemployed and homeless.
So instead of, developing something in the lab in a bubble for 10 years, you should, at some point ask that, would you be willing to buy? Would you be willing to buy this? So in that study, that it's indeed possible to make a synthetic virus-like particle that blocks COVID infection by 72%.
So the reason why you risked everything is because you saw that this has actual potential to help humanity.
Yes.
So it was worth being penniless for.
Innovation is key to the human success. So without innovation, we will fail for sure. So please innovate and be brave enough to try. And even if you fail, then you learn from that and then you try again.
So Erik, tell me, what is your story?
I started thinking of inventions early on. I think that's maybe the story. Maybe it started from those car trips to the countryside, maybe, because I remember that sitting in the back seat, it was always a bit boring, as you know. So my older brother, he just wanted to read books, but I enjoyed going to my own kind of mind or abstract thinking, and then I tried to build things in my mind. So I think it grew from that already at the early stage. And then fast forward that to my education at Åbo Academy, when I started working with cell biological things and nanomaterials. So
What motivated you to study nanomaterials?
yeah, so that's also going back to my childhood. So when I was a kid and had a flu or something, and then you go to the doctor and then they said, yeah, take this painkiller. And then I was like, why?
Why?
Yeah, why should I take this? Doesn't it just take away the pain, the symptom? It doesn't cure me. And the doctor was, yeah, you're right. And then I was like, yeah, why did I take this then?
Well, you were a difficult child.
Yeah.
A curious one
Yeah.
as well.
So that's why I wanted to study cell biology, to understand the why.
So I'm happy that we're going back in time, and I would like to take us back to this notebook, because it says here, Erik at 10 years old.
Yeah.
What does it say here?
Uppfinningar.
Uppfinningar.
So it's Swedish, and in English it's inventions.
Inventions. Okay, so I
Yeah.
see we have a few inventions here.
Yeah. So first of all, I kind of tried to re-engineer Spider-Man's spider web machinery, which he has in his arm. So you can see the syringes and pressure gauge and
Oh my God.
picture of the device.
So you are representing the device in 3D
Yeah.
at 10 years old. Wow.
Yeah.
That's impressive.
Yeah.
So that's the first invention, a Spider-Man improved web slinger.
Yeah. And then there's another funny thing here, making a stiga like this kids
Like a sledge or
sledge, go faster. So you put on a motorized engine, from a chainsaw or something.
from a chainsaw.
Yeah. And then you get more speed.
Oh my God. You were thinking outside the box.
Yeah. But I would say that one of the coolest thing is here this magnetic levitation system. So
Okay.
yeah. So I envision that in the future you have these
Is that a
pods.
car?
It's like a car or a train. So beneath the cities you have these magnetic tunnels, and then you have a magnetic levitation pod that can transport goods and people between cities. So no noise, no emission, no.
So from levitating to nanomaterials.
Yeah.
And if I understand correctly, when you started studying cell biology, your innovations did not stop in this notebook, but they even continued.
Yes. So I was lucky that at Åbo Academy there was a prestigious nanomaterial group from Jessica Rosenholm. And then I think I just went to her office and asked that can we do some nice studies together. And then I wanted to combine the nanotech with cell bio. So then I asked the professor in cell bio, Jon Eriksson, that can we do this collaboration, get the expertise of your group and then the other group to make some new cool stuff. And then we started with that. And one of the maybe coolest inventions from the PhD was making these sugar-coated nanoparticles. So the idea is that cancer cells, they have so high metabolism because they grow fast. So they eat everything, like all the sugars in the blood. So the idea I had that why don't we make a nanoparticle with sugar functionalization? So then it goes to the cancer cell and then you load the particle with some kind of drug that kills fast dividing cells. So that's what we did, Celastro loaded sugar nanoparticles. And back then I was, I don't know, 25 or something like this, young and naive. So I took the idea, made a nice poster with my colleagues, and then we went on a seminar. And then, yeah, super cool idea. Explained it to the whole crowd, and then even the abstract was uploaded to the internet. And then, I don't remember, was it me or the professor or the tech transfer officer back then that said that, Erik, you should make an invention disclosure to the university. So we did that. And then, well, again, this is cool, but sorry, when I Googled this, you found immediately the abstract and the poster. And they're like, I'm sorry, this is, disclosed, so your own disclosure, the poster is, hinder for patentability.
Whoops.
Yeah, so that was a tough lesson learned.
So the lesson is that if you have like an invention, you don't want to disclose it right away.
No.
Okay.
Yeah,
okay.
That's an important aspect. So patenting doesn't mean that, you don't tell anybody anything or, hide it under the rug or something. No. It's just filing a patent application legally stating that you invented or your group invented this, and then it has a timestamp. So after that, then you can disclose. But you need to do the patent application and file it first.
Okay, got you.
Yeah.
But then the excitement that you had. I mean, think about it. You're sugar coating a bomb for cancer in a way. You're like sugar coating the drugs, and you're like, hey, cancer, you want to eat this? It sounds like something that humanity can benefit from.
Yeah, definitely. And I don't know, to make more depressing or happy that publication from that study is now cited almost 100 times.
Wow, 100 times.
Yeah, so that's, in science world quite high. So it's a cool study.
Quite high, or maybe among even the highest,
yeah,
if you think about it.
Yeah,
this is a lot of citation.
Yeah, it's like top 1% of all publications get around, or more than that.
That's impressive. That's impressive. Well, I suppose then maybe you didn't make a business out of it.
No.
But you kind of benefited humanity on the other side. So
yeah, maybe.
Sort of.
Maybe.
Is it sad or is it happy? I'm not sure.
Exactly. But at least I learned a lot from that, and back then I didn't know that much from the business side. So.
Okay, so then was this it in terms of innovation? Did you get like demotivated and you're like, you know what, that's it, I call quits?
No, that's a good point as well, and I think that everybody should fail at some point, and because it's a good lesson to learn, and then you try again, and now in the second round you have better tools, better knowledge, so then it gets better next time. And during my PhD and the time around that, we were also working with materials to be coated on surfaces.
Okay.
So we made this kind of nanotopography coating. So the idea was there that traditionally you grow cells on plastic.
Okay.
And plastic, as we all know, isn't very environmental friendly. And it's artificial, so it's not the same as your own like flesh and blood. So what if we can replace the plastic? So the idea was that why don't we use like paper or cardboard, and then we just coat the surface, enabling cell growth on the paper.
Wow.
Yeah. And the best part was that we could kind of modulate the surface so it grows for specific cells. So it's kind of, if you would say that plastic is 2D, like two-dimensional,
okay,
and like the human body is 3D or even maybe 4D, this kind of coated would be 2.5 because it's closer to the real situation when you have the topography.
And it's you're saying it's 2.5, 2.5 because it's not just on a flat surface,
Exactly.
but it's on a surface that has little
textures.
Okay, so the cell could be like a bit to the right, a bit to the left. Okay.
Yeah.
That's very interesting.
And this time we did not present first. So what we did this time was we filed a patent application with Åbo Academy and then went to our poster and then published the results. So we didn't repeat that, or I didn't repeat that mistake. But back then I was still young and kind of, I don't know, I call it like this Santa Claus illusion that many academics or maybe students have, that somewhere from above, or Santa Claus comes and give you the present, the money or whatever to make it reality. But this is not the case. You have to drive the innovation forward. Nobody else gonna do it.
Not Santa?
No.
Oh, damn it.
Yeah. So in that case, we were waiting and waiting and waiting, and because time went by, the team kind of disintegrated. So one went to Norway and one other went to another university, and I then moved on as well. So then it's difficult to bring in the team, because that's one other reality, that innovation don't fly solo. Or at least very difficult. You need like a interdisciplinary team. The team should also be a bit from different backgrounds, right?
Exactly.
Yeah.
Exactly.
Every great innovation starts with a eureka moment, but turning that spark into something real takes much more. That's why we help build From Ideas to Innovations, a course for people who want to do something with their spark. It breaks down exactly what stands between an idea and reality, the IP, the funding, the right people, the market fit. And through the series, you'll hear the stories behind those innovations, real conversations brought to life with the support of our partners, Varha, the University of Turku, and Åbo Academy University. Subscribe to our series and check out the course link in the description below. And now, let's get back to today's guest.
Speaking of team, how did you choose that team? What's your philosophy in choosing a team?
Very good question. And I'm a big believer on this organic growth, that you grow your team organically. And what I mean with that is that you meet people in real life, and then you kind of feel the synergy, you feel the click. So that's how you build a good team. You take different cultural background, different expertise, and then you discuss together and move forward. Because let's put it like this, you have like a great invention, and then if your team is only academic, okay, great. So let's say I would be the expert in the cell assays and you would be the expert in animal studies. Okay, great. But how about, the finance? You run into bankruptcy in 1 year. What about the operational guy who juggles, with the taxation and salaries and what about the, negotiations and deals and contracts? Now you're in trouble. So you need this kind of diverse yet unified team to make it fly.
It sounds like there's going to be a lot of pitching to kind of get those people on board.
Yeah, but the team building is, I think it's more natural. So when you talk with people, it's more natural compared to pitching to investors. That's, of course, pitching you can also be done in different ways. For example, we are a bit jumping here, but my own startup, the pitching has been quite different than many like venture capitalist-based companies where you have like the formal pitch and you go to a pitching event. So the pitching in my case, it's more like the fool's friends and family and your own pocket. So you're pitching to, you know, people that you already know, that trust you from the past. So one example that I can give you is that the anchor investor for the company was the founder of Motonet.
Oh,
so you know, yeah. So the car dude.
The car dude. So Motonet is more like a website that sells car parts and
and whatever you need.
And cars as well. And
no, not cars, but car parts.
Car
and
parts.
Like all the consumables for cars. So he's a family friend.
Oh, so he's one of the 3 F's: friends, fools, and family.
So I've known him for a long time, and it's through my wife's family. So they know them for like the childhood. And when we were students, we used to come there and have like these evenings where it was actually like he buying the food, we cooking it together with his spouse, and then eating together. So bringing talent together, because cooking was not maybe the best, you know, trait of him, but then he could afford, compared to poor students, like some nice meat. But anyway, so the point was that he already saw from the beginning that maybe there's some potential in this dude. And then when I called him and said that now I have a great invention and now we need some funding to build this company and make it reality, then he was like, yes, how much do you need? So the trust was built in like 10 years.
10 years of eating meat?
10 years of, you know, whatever, going fishing.
Connecting with them. So it seems that this organic approach is actually ingrained in almost everything you do. It's not just with getting the team, but it's also with even how you talk to people and how you... Wow. That's...
Because you never know the people you are talking with. They could be the key for your success. I'll give you another example.
Sure.
The sports events for my kids in the evening. So then there are other fathers and mothers, and then you talk with them, or at least I talk with them. And then, okay, this guy is in the finance, pretty wealthy guy. And then you pitch to him. And then it ends up that he's one of your future investors. So every moment is a possibility.
True. But that also requires us to come out of the lab.
Exactly.
You're asking for too much air.
Yeah, so you need to go out. Isn't it Mulder and Scully from that the truth is out there?
It's out there. It's not in the lab. That's a very, very powerful point, and I love how you made it very casual also. Like, it's not like you're suiting up, you're going to pitch. No, it's more like, you know, I'm out with my kids. They're playing their sports, and somebody's next to me, I can talk to them, and we can have a nice chat. I ask them what they do, they ask me what they do, you know? And so on.
Organic.
I like that. Very, very nice. You mentioned something interesting about finance and business. What would you say, like, one of the things that you learned along the way when it comes to specifically those skills? I mean, you know, we in academia and inventors and researchers, we don't really think about that part.
So the funding for startup, in a way, it's similar to academia in the sense that many academics, they need to apply their own funding, right? It's not like given from above. you have to like fight for it.
Yeah,
So
no
there's
Santa.
no Santa. So there's the similarity, but the difference comes from that a company, if you go close to bankruptcy or cash flow issues, then you are like the snowball effect of the downward spiral can start. Whereas in an academic setting, you can still survive with quite low, okay, this year we didn't really get that much funding, but next year we get. So it's okay to be in this kind of fluctuation. Whereas a startup, if you go to cash issues, it can be a big problem. Like for example, if you get like a government funding or a government loan, yeah, you get the funding, but first you have to generate cost and pay it from your, own equity.
Yeah.
And then you get reimbursed later. So meaning, let's say the animal study of your startup will cost several €100,000, which might be the case. So then you need to have a positive net in your bank account to do that study, pay it first, and then get reimbursed later. So these kind of things has been like a reality check for me. So you need to think about smart moves and not like many academics that you try around and it's not so bad if you fail, in the sense that you can always try again. In the startup, in the deep tech, yes, it's good to try and it's okay to fail, but the fail rate cannot be that high because then you go into like these cash flow issues. The other thing also in my own case, that even if you invent a great idea, a concept, in this world when and everything runs around money, who is willing to pay for it? So instead of, developing something in the lab in a bubble for 10 years and then like, oh, maybe you should, at some point ask that, would you be willing to buy? Would you be willing to buy this? And then it's like, if the feedback is, maybe if you tweak it a little bit, or maybe if we tweak it to like an annual fee or monthly fee instead of, here's 10,000, or, this kind of things matter a lot. So getting feedback from the customer or from the world. Mm-hmm.
That's very sharp, actually. Mm-hmm. And how do you know who's your customer?
That's why you need a diverse team to help with these questions. So you might think that the customer is the end user.
Yeah, for example, makes sense.
But maybe in reality the customer is a research organization or a company. So you are like off your target when asking the end user. You should maybe ask that, hey, I have this cool invention. We can produce something much cheaper and faster. Then the end user, maybe the patient, doesn't understand anything. So you need to ask the big company and then you pitch that, hey, we can produce this protein or this drug more affordably. And then they're like, oh, nice.
Mm-hmm. Then it will make sense to them to buy it.
Exactly.
And from them, they will get to the mass.
Mm-hmm.
That's a really nice way to think, because I feel like one of the most beautiful things I've witnessed with innovators is that they're always looking at how to make the world a little bit better. Mm-hmm. It's always like, okay, this is gonna make their lives better, but not necessarily they will be your customers, or they will pay directly to you for it.
Yeah, this is something I'm still an idealist in the way that hoping that inventions will help mankind, but then with a hint of reality check that if you just disclose publicly your invention like I did in the past, then who's gonna bet money on your case? Because then you don't have any tangible assets. Then you don't own it in a way. Then you just throw it away for everybody to use. And especially in drug development, when it costs like I think it $1 billion is like something like this, a traditional drug. So if you don't have the patent, you don't own the invention, then who's gonna back you up?
That's a nice way to look at it.
Yeah.
So this is new for me. It's a new framing. So instead of I want to share it with the world, no, I first want to patent it to be able to share it to the world, because that way I can get somebody to bet on this, to grow this, to develop this. But once it's out there in the world, nobody really can move it forward as much. Is this sort of the...
Yeah, and then like the original idea, a patent, it's Latin and it means to lay open. So it's in a way to lay open to mankind, but still you own it. So you can, during 20 years or so, exploit it and make some business from it. And if you're the founder and biggest owner of your startup, then you can decide in the long run that if you get wealthy, well, then you can donate that or make a foundation, a foundation that will have other inventors. So then you can, help in that way as well.
Continue the cycle. Sort of pay it forward.
Exactly.
Oh, that's beautiful. So then, Erik, you took us on a beautiful journey from the young innovator to the person who's telling all the world about his amazing invention that he could have patented, to patenting it and actually waiting for a long time until nothing really took off and Santa never came. Did you then try to patent again or try to innovate again?
Yeah, so there's still one invention that I haven't talked to today about. So that's during the COVID, so when it was a global pandemic in the spring of 2020, I actually had this nightmare that the COVID virus will continue to evolve and jump between species and humans back and forth and become very nasty. So then I thought about, what if we utilize kind of the viral properties? What if we make a synthetic particle that mimics the virus? So you would apply it or inhale it, and then it will give you a protection, a little bit like sunscreen that you put on your skin. But this viral particle you would inhale, so it would be on the inside. So the synthetic particle then physically blocks the virus from entering. So this is something I invented when I didn't have any contract, so I was unemployed. Yeah, and then my soon-to-be co-founders told me that this is a great idea, so you just use your money and file a patent application on this, and then we see how the journey will go.
So you're asking the unemployed person
to
put his money?
Yeah.
Okay.
Yeah. So that's what I did. I used my last money for that and then pursued the development with my own money, but of course realizing that won't get me very far. We started raising funds and discussing with these friends and families. And then quite roughly 1 year later, then we founded our company and raised some funding, and then the development started, like doing the R&D. And if we wouldn't have funded our company and raised the pre-seed money, it would have been game over, because I put all my savings on the patenting fees and R&D development.
So you wouldn't have just been unemployed, you would have been unemployed and homeless. Wow.
Maybe not homeless, but penniless.
Penniless. So much on the line.
Yeah.
What made you take that risk?
The genuine idea of the world needs this kind of solution. So it's not enough to have drugs against viruses. It's not enough to have a vaccine. You need something proactive. So when you go to a meeting or airplane or somewhere crowded, you could take this solution and then you would be in a much better protected state.
This is powerful. So the reason why you risked everything is because you saw that this has actual potential to help humanity.
Yes.
So it was worth being penniless for.
Yeah. And now we have, from last year, a very cool publication that was actually selected for the front cover.
Amazing.
Yeah.
So you made it to the front cover of the journal.
Yes.
Oh, so a featured article.
Yeah.
I see. And that's from the idea that you talked about. So you're using sort of the idea, the analogy, you used the beautiful analogy of a sunscreen, but your internal kind of like on your lungs.
Yeah.
So that you're able to protect against the viruses.
Yeah. So in that study, we showed in cells that it's indeed possible to make a synthetic virus-like particle that blocks COVID infection by 72%.
Wow.
Yeah.
That is like sunblock in a way.
Yeah.
But COVID block.
Yeah, exactly. And then from that, we have now been working on doing the animal studies, so the safety studies. So what will happen to the transgenic animal when it's inhaled? And hopefully we get that study published in the summer.
In the summer. Wish you all the best.
Yeah.
And then, of course, I understand there's a lot of secrets now because we're still working on things. So you're not able to open a lot more. But you already gave us something really insightful that I would love to focus on. The way you explained all your innovations was superb.
Thank you.
You're welcome. Coming from science pictures, I'm like, ooh, I need to take notes. Because pitching your science or speaking about your science, it takes an art. And you use the beautiful metaphor.
Yes.
All the time you're using metaphors to explain it to me because I'm not as smart as you. I don't know what you're actually inventing, but you're breaking it down. This is something I think that's very beautiful, and I wanted to ask you, was this something you've always had? This like skill of breaking down hardcore science into simple sunblock, sunscreen analogies?
I would say that it's years of practice. But then an anecdote from childhood again. So when I was young, I wanted to be good at something, and my parents wanted me to try different things, and I was not eager to try. So I have been playing like football. I was semi-decent on that, but not super good. Played, badminton, and then I actually played the clarinet, but that one I wasn't good at all because I have difficulty reading kind of the notes. But doing that and kind of being forced to present crappy music to 500 people makes you kind of, well, if I can survive that, then maybe talking to somebody is not so bad. So that has helped a lot. So kind of giving the courage to once again failing in front of an audience. And the world doesn't end from that.
The world doesn't end from that.
No. And then pitching with your voice, it's much easier than playing an instrument that some genius have written like exactly how you should play it. Because when you're pitching with your own voice, you can correct kind of in the fly what you're saying.
Very true. Apart from a clarinet and you have a piece and there's like, oh my God, that's very embarrassing.
Yeah. And then I think partly also my father, he's now retired, but he used to be pretty hardcore negotiator. So I've been like seeing him from the childhood of the skills of kind of making a crystal clear communication, like explaining things to people from different kind of backgrounds to keep it simple. So that I learned a lot from him.
Nice.
And then the creative side is more from my mother's side. So I get the good blend of both worlds, the Swedish creativity and the Finnish sisu.
Nice.
Yeah.
that perseverance. I'm gonna do it, regardless of the clarinet, regardless how many people are looking at me and laughing at me, but I'll still pull through.
Yeah, but I'm not gonna, sugarcoat the startup life. It's not easy, and
it's not easy.
Sometimes I have my, doubts and uncertainties, but then you just move forward and then try to steer the way. That's like the only way to. I think Albert Einstein put it quite nicely that life is like bicycling. So if you stop, you fall. So you have to have some kind of momentum to stay on track.
Just keep going forward.
Yeah.
Regardless of what happens.
Yeah, I think that's the worst thing to do is not to do anything, because then for sure you fail.
Yeah.
So if you're, stressed about your invention, that will it fail or not? Well, if you do nothing, then for sure it fails. And if you try and fail, then you will learn something from that, and then in the next run, you'll be better. So I'm hoping that this kind of taboo in Finland, that failing is so bad, I'm hoping that we get rid of that it's okay to fail, it's okay to try. And that's the most important thing, to try.
To try, agreed. What if I put you on the spot now and tell you have a 30-second pitch to tell our audience why they should innovate and why they should fail? Sorry.
Yeah, I try my best.
Sure. Whenever you're ready.
I would say innovation is key to the human success. We have all kinds of challenges in the future, so without innovation we will fail for sure. So please innovate and be brave enough to try, and even if you fail, then you learn from that, and then you try again, and then you get better from each iteration. So that's what I'm hoping, that please try.
Wow, please try. This was amazing. Thank you so much, Erik. Tack så mycket.
Tack så mycket.
This was a beautiful journey. You took us from all the phases of not making a patent to making a patent and not doing anything about it, then making a patent and doing something about it, to even you showed us also the organic team and how the team would be kind of following you. So then I want to ask you, if again this is another thing, but if somebody would tune into this episode, why would they listen to us speaking?
Well, listening to somebody who already have tried, then you might avoid some mistakes in your own journey. So that's maybe the most important lesson. So for example, if I would have known not to disclose inventions prior to patenting, then maybe there's already one success story, who knows?
True, who knows? And how would you professionally present yourself?
I think I would say something like innovation expert. Yeah.
Innovation expert. And if somebody has an innovation in their hands, what do they do? What would be the next steps for them to take if they have an idea?
Well, first try to check if there's something similar. Is it novel, inventive, and technical feasible? And then kind of contact some patent attorneys and think about filing that patent application, and then how to proceed forward. Do they need more R&D? Do you need more funding, or is it more academic research, or what's the pathway?
Okay. Are there certain, let's say, people that they can contact? For example, can they contact you? Can they contact the technology transfer office?
Yes. So if you're employed by the university, then please contact the tech transfer office. Then they can help. And at Turun yliopisto, also student can ask some advice from the tech transfer office, even though students usually own their own inventions because they're not employed. but we can give some direction so they can, proceed.
I think you're the best person to know about this, being unemployed and putting your own money and savings into an innovation.
Yeah.
Thank you. This was beautiful.
Every great innovation starts with a eureka moment, but turning that spark into something real takes much more. That's why we help build From Ideas to Innovations, a course for people who want to do something with their spark. It breaks down exactly what stands between an idea and reality. The IP, the funding, the right people, the market fit. And through the series, you'll hear the stories behind those innovations. Real conversations brought to life with the support of our partners, Varha, the University of Turku, and Åbo Academy University. Subscribe to our series and check out the course link in the description below.